Hello students, welcome to the fifth lecture in real analysis. In this video lecture, I will be discussing the concept of closed spheres. In my previous video lecture, I have explained in detail the concept of a open sphere, and this concept also is on the similar lines, right? So let us read the definition of a closed sphere. So for this, I will be considering XD, which is any metric space, and capital X be any point from this set X, which is obviously a non-empty set, and R be greater than 0 be any real number, right? Then the closed sphere with the center X and radius R, right, generally denoted as SRX, okay, is a subset of X which is given by, that is, it is the set which is the collection of all the y's coming from capital X such that the distance between y and x is less than or equal to R. So let us recall, in case of open sphere, this was distance between x and y strictly less than R. So the main difference between the open and closed sphere is nothing but the equality sign. So now let us see few examples which are based on closed spheres. Usual metric space R under U, the closed spheres, they always look like x minus R to x naught plus R, and the brackets are closed. Now why this happens? So let me describe it below. So basically, if I say S, so it is having the center x naught and radius, let it be R naught, right? So it is nothing but the collection of all the y's, fine, that is coming from capital R, such that the distance between x naught and y is less than or equal to R naught. Fine with this? Now again, that is, it is the collection of all the y's coming from capital R, such that, now what is this distance? This is under usual metric space. So x naught minus y is less than or equal to R naught. So again, if you solve this, if you go on solving and solving, so what do you get if you open this inequality? So this will be from minus R naught to plus R naught, right? And just this will be less than or equal to x naught minus y. Fine with this? And now what we are required, we want to know what is the value of y. Now since we can use a property that mod of a minus b or mod of b minus a, they are one and the same thing. So I can write it, that is, this x naught minus y modulus can be written as y minus x naught modulus. Fine with this? So now if I write it down, y minus x naught, so it lies between minus r naught to r naught. So finally, what is my y? So the collection of all the y's coming from R, such that, now just add x naught on both sides. So this will be x naught minus R naught less than or equal to y less than or equal to x naught plus R naught. So that is just the closed sphere in this case. So you can just see that x naught minus R. So here it will be R naught if I have considered the center to be R naught. So this will be R naught. So x naught minus R naught to x naught plus R naught and the closed intervals. So I hope this example is clear to you. Similarly, if we have another example in the usual metric space, complex under usual. So if I consider the center to be z naught and radius r, so that is a circular disk. So in this case, the closed sphere will be nothing but z minus z naught less than or equal to r. So z naught is the center and r is the radius. So in this case, this dotted line will convert into the real line. That is, so you need not to draw the dotted line in this case. Fine with this? So that the boundary will also be included in this case. Moving on to the another example, that is XD be a discrete metric space which is defined as D under D basically. That is, if x and y they are not equal, so the answer comes out to be 1, and if they are equal, so the answer comes out to be 0, right? And so in order to discuss the closed spheres in case of a discrete metric space, I will write the definition, that is, it is the collection of all the y's coming from the space such that the distance between x naught comma y is less than or equal to r. Now we take the three cases. Case 1, if my r is lying between 0 and 1, let me say that if r is equal to half. Fine with this? So it is basically the collection of all the x naught with the radius half, right? So that is, so what will be s x naught with radius half, that is the collection of all the y's coming from x naught xd such that the distance between x naught and y is less than or equal to half. Now you can easily see that the distance between x naught and y, either it is 1 or it is 0. So it will be 0 if x naught, right, is equal to y, and if they are not equal, the distance is equals to 1. Now which distance it satisfy? Is 1 less than or equal to 1 half? No, it does not satisfy. Only this thing satisfy, that is 0 less than half. So whenever if I take the radius to be strictly less than 1 and greater than 0, so only distance between x naught and y that is equal to 0 satisfy this inequality. So in that case, when the distance between x naught and y is equal to 0, if and only if x naught is equals to y. So one thing is clear, whenever my r is lying between 0 and 1, so the closed sphere in this case, now generally I will denote the closed sphere as this. So whenever my r is less than 1, so the closed sphere in this case will be nothing but the singleton point x. Now what about if r is greater than 1, right? So let me take r to be greater than 1. So case 2, r to be greater than 1. So let me say that r is like 2, right? So the collection of all the y's coming from xd such that the distance between x naught and y is less than 2, right? So generally I will denote s of x naught with the radius 2. Now you can easily see that my inequality 0 is also less than 2, 1 is also less than 2. So both these points satisfy. So basically my all the points from the space will satisfy this condition. So if r is greater than 1, so the whole space that is x will satisfy this condition. But the main difference will come when r is equal to 1. Actually students, the main difference between the open spheres and the closed spheres always arise in case of discrete metric space when r is equal to 1. So let us discuss that case so as to make you things more clear. So if I take my r to be equal to 1, now what about the closed sphere? So S1 with x naught radius, that is a collection of all the y's coming from xd such that the distance between x naught and y is less than or equal to 1. Fine with this? Now you can see when the distance, so 0 will also satisfy, 1 will also satisfy. So it means every point from the space will satisfy. So the closed sphere in this case when r is equal to 1 will come from this capital X only. So all the points from capital X. So equality will come this side. But what about the open spheres? Now let me recall also for you guys. So the open sphere in this case, so when r was equal to 1, so when r is less than 1 or when r is greater than 1, here also it was singleton, here also it was x. But what when r is equal to 1 and when we are talking about the open spheres? Now just students remember, so when r is equal to 1 and we are talking about open sphere, so here it will be strictly less than 1. So 0 only satisfy this, 1 does not satisfy this condition. So only 0 satisfy, it means when the distance between the 2 points is 0, only when the 2 points are equal, right? So only singleton will satisfy in this case. So the open sphere in this case will, when r is equal to 1, will only be the singleton point. So that is the major difference when we are talking about the open spheres and the closed sphere and r is equal to 1 in case of a discrete metric space. So that is the major difference. So I hope this point is clear to you. Now, the last example in this video lecture, that is we are asked to calculate the closed sphere in R square. So basically the distance between the 2 points in R square is generally given to me as x minus x1 minus y1 square plus x2 minus y2 square and whole under root. So what if I'm asked to calculate the closed sphere with the center 0, 0 and radius 1? So just apply the definition, that is with the center 0, 0 and radius 1. So it is the collection of all the tuples, that is x1 comma x2 coming from R square such that, so just apply the points. So that is x1 square plus x2 square will be less than or equal to 1. So that is the collection of all these points. So just see in this case, this dotted line will again convert to the closed line. Fine with this? So the boundary will also be included in this case. So that is the basically the set of all the points. So if I write for this case, so in R square, closed sphere is the, so in R square, the closed sphere is a called a closed disk. So generally it is called as a closed disk. So I hope things are clear to you. So my upcoming video lecture, we will be discussing and exploring few more concepts dealing in real analysis. So I hope you have enjoyed this video session. For more such videos, do subscribe to my YouTube channel and do not forget to press the bell icon. Thank you.